what we're going to do this next hour is we're going to walk you through, it's called like a diary of red team pen tester. So, talking about the intrusions, I think one of the most important things in order to come up with the right security mitigations is to actually really understand what an attack looks like. And the reason we call this a red team is because we want to simulate the more advanced attacks. So the traditional attacks are pretty flat. You find one vulnerability and then you walk through it inside to next vulnerability and then you hit your goal. In the more advanced attacks, like the nation-state sponsored attacks and the attacks we see nowadays, people tend to find one small vulnerability over there, another small one over there, and then they can combine them in order to get access to a system, for example. So that is something any automated scanner would miss. Basically, any quick pen test would miss that too. But people with time and intent and capabilities, they will find all these small things, put them together in order to get into your networks. And this is why there are so many successful attempts. So, Fabio, let's draw a small map here, and maybe you want to introduce them to the concept. Fabio is actually the lead tester. He basically runs every red team exercise we do right now. So we have a strong team, but he's the more structured guy who will keep everything in order.
All right, so this is a kind of a generic overview of the way to proceed when you do this kind of red team exercises, which is also how criminals think in terms of reaching a specific goal. So basically we have, well, we can see this as different layers, right? From external to all the way to the high value targets, HVT. That would be, well, that would change depending on your target. Can be, well, depending on what you're after. It can be information stored in a specific database. It can be a mainframe where transactions occur. It can be, customer data, depending on who you're attacking. So that changes.
Yeah, the typical question when you start this is, what would be the worst case scenario for your organization? You will probably find that around the high value targets.
Right. Then, well, first thing we need to do is to somehow find an entry point into our target organization. And, well, that can be done, well, in different ways. Normally, it is categorized in internet attacks or whatever is exposed on the internet. Some of these systems here that you can reach directly from the internet, your websites or mail server, VPN endpoint, and whatever is exposed for everybody on the internet. We have clients, of course. We can do client-side attacks. That can be another entry point. We can walk through the door into the building and plug a device into the network. So this would be different entry points. And once we have an entry point, we want to escalate and expand our influence in the environment. And, well, depending on where you are and what privileges you have at the moment, it can be more or less time-consuming. But ideally, you need to expand enough so you have enough credentials and reachability to access what we call here central management systems. This would be, in a typical case, a domain controller if you have Windows domains. Otherwise, it could be a specific management segment where you have certain credentials or deployment solution. I mean, something that is central, that if you own that, then you control virtually the entire infrastructure.
And this is a place where people sometimes have a false sense of security. We see scenarios when we do these red team exercises. For example, they have this network that is completely logically isolated from the internal networks. They actually have a firewall and they don't have any rules. So the network is defined in case of emergency, but there are no rules that will allow any traffic in there. We see that in more of a military style scenarios. We just compromised the firewall administrative consoles. And then we get there. So it's anything that is central management or complete is anything that can give you access to the high value targets. So you have to realize that the attacker will be really creative. if there's any way to get to that data, they will also try that.
Right. So exactly. So it has to do either with compromise specific parts of the network or specific devices or systems that will allow you to reach your final target, or specific people. It can be a few key people in the organization and have access to what you want to get to. And you can target those specific individuals.
I think the best way of showing this is to actually demonstrate the attack. What do you think?
Yeah, that sounds good. And more fun.
More fun, yeah, of course.
OK, so let's start with some live demos. We're going to show first an example of targeting something that is exposed on the internet up here on some website. Now I have an example of a website for a gym. Now, this could be anything that is hosted on your infrastructure, not necessarily related to your business directly. I mean, you can have whatever reason why that's hosted there. You might not even remember you have that site there. It was a test or something. You know, when you have large enough exposure, you often end up with something that was there and you didn't remember, or something like that.
Have we ever, in the real red team exercise, found one environment where there were no forgotten or relaxed websites?
No, if the organization is large enough, no.
Oh. It's kind of interesting. Have we ever failed to break in from the internet through the web infrastructure?
Nope.
So I think that's lessons to learn.
So let's browse around this site. Now, we're going to try and search for members that are registered in this system. And we're going to try if there are some well-known vulnerabilities on this site. For example, a SQL injection, a classic web vulnerability that's still on top of the list. So, you know, as an attacker, I can look at how the website behaves and try to guess what's going on behind the scenes. Now, I'm sending some parameters. The application is retrieving data from me. I can kind of guess there is a database behind there. This parameter is most likely used to make a query, and we can try and break that query and possibly end up in a SQL injection and exploit that. Now, I'm going to go through this quite fast. We're not, going to explain how SQL injection works right now, but the idea is that if you look what's going on in the background,
can you make it a little bigger? Yeah, good.
You have all your requests that your browser makes against the application. And we can see that when we send information with our parameter, there will be some data that the application returns. So we want to try and break that. So what we do is we try to add special characters like a single quote that will break the SQL syntax. We send that request, and we don't get anything back. Now, this doesn't mean that the application is not vulnerable just because we don't get any output. So I know for a fact that this is vulnerable. And a way to try and figure out if that's the case when you don't have any output is to use, for example, delays or other techniques that will tell you if you're successfully injecting.
Yeah, you need some kind of feedback from the web application. So just telling it to wait, even though you will not get any text, you will at least see that it's stalling.
That's right. So let's try and send a delay of 10 seconds. And you have a little waiting sign here, but we don't see very well. But we're having a delay until we get the response of approximately 10 seconds. There you go. So we know we're affecting the query. So that's a great start. For an attacker, we have a SQL injection. Fantastic. Now, this can go bad or worse from here, basically. So let's first try to figure out if we can extract information. I'm going to use a technique called union to, in this example, take the version of the SQL Server behind this application. I'm actually going to do this directly from this web page. It's nicer to look at. So I'm going to paste my input there, and I'm going to actually get the version of the SQL Server. So I'm injecting a query and extracting information. I verified that I could do that.
For demo purposes, this is kind of a nice output, but normally we would maybe have to catch it in the web proxy we're using or something. Yeah. So now we can steal things from the database, right?
That's right. I mean, if our goal is to penetrate this network, we want to execute code on, well, in the first stage, any system, and then on specific system, but we want to run code. So that would be possible if we have enough privileges in this database. So we need to check what identity we have as a SQL user in that database to figure out if we're allowed to run commands on the operating system. We are an account called Jim1, as the name of the application. We want to check if we're a sysadmin in that database, because if we are, then we can run code on the operating system. So we're checking if we have that role, and we're returning yes or no, depending on the result. But we're not, right? So this would be the common case. If this is an application exposed on the internet, there will be some basic hardening. You really shouldn't be a sysadmin. So that's good.
So this is where the more automated tests would stop. They might just get to the fact that they can extract data, but they wouldn't get through the SQL server. And they would just start look for the next exposed application.
Right. Well, we can extract data. So let's check the name of the database that we currently are operating in. Oops, shouldn't have sent that like that. It's an AJAX call. So. Right, so the database name is Jim1DB All right. So what information do we have in that database? Let's get all the tables in that database.
And these simple demos are just normal things from real things we do every time. It might be a little trickier, but the principle is exactly the same.
Right, so these are all the tables in that database. Now, well, there can be a lot of information here that I could potentially reuse to access other systems or applications. One thing catches my eye directly, web admin logins, which sounds pretty interesting. So let's see what columns are in the web admin logins table. We have 3 columns. We have login, we have pass, and default URL. OK. Let's see what the content actually is. So this is what we're going to do. We're going to select the login. Then we put a dash pass and default URL. And this is what we get. So there are 2 entries in that database. There is a username, a password, and a URL.
That's a good password, by the way.
Yeah. Too bad it's clear text.
And if this was like the breach on some big website like Yahoo or something, maybe this could give you 500 million identities. It could just be a SQL injection. And they're worth pretty much. Even a credit card is nowadays, a European credit card is worth $25 to $30. So Magnus Lagerquist, I'm not going to sell yours. I'm going to give it back. I didn't steal it, he lost it. So you should keep your data safe at all times. Oh, shit. Well, I only got it a few minutes ago, but...
All right, so obviously, we can try and reuse this information. We have the site adminconfig.etherrip.com, and we have a username and password that will probably work to log on there. So let's go there. Now, this is an admin config portal.
So this is the typical red team scenario. You find something on one site, then you parse the infrastructure, and then you find some portal or something somewhere else, and you reuse that data.
Here we are. We have some sort of admin functions on this site. We can change a logo. Some of you are already smiling. There is a file upload function. Well, as an attacker, a file upload function is extremely interesting because if you manage to break whatever restriction might be in place, you can upload arbitrary files and in most cases run code on that system.
I'd say we find this in almost half of the large environments we're assessing. File upload vulnerabilities.
So. Yeah. And now the fact that this is in some sort of admin portal that only specific users should have access to is even better for an attacker, because those type of portals or functions are usually not as restricted as others, because only admins have access to it. So I think in all our demos we have shown so many examples of broken file uploads. We can basically just exploit one.
Yeah, just cut to the chase.
That's
Send
right.
an evil...
We're going to send an evil evil JPEG
image.
shell. Thank you. OK. I'm going to upload that. That worked. We're going to see where that was uploaded. Copy image location. We're going to browse there. This is our image.
This is an image, so the validation function of the application will accept this as an image.
Except we appended something extra at the end. A small remote management interface where we can actually run code, ipconfig or something. And we have the output here. And we can, browse the file system, upload other files, and basically do whatever that application can do on that server, right? Because we are acting under the identity of the web application. That's what's running code. OK, so who are we? Who am I? We are the app pool account for the application admin config. Again, that's good. It's expected configuration for exposed systems.
Yeah, again, nothing is relaxed here. This is what it usually looks like. So this is not a local admin or system account. But many people don't realize that you can still upload all your files, you can still execute code, and you can still use network resources. So this is good enough.
OK, so let's go back here for a second. We have found, if I manage to do that.
I want to draw. My mother's an artist. I didn't inherit it. So this was a SQL injection, right?
Mm-hmm.
Here we had some SQL data. And then we find this file upload somewhere else. And that gave us the opportunity to execute code on this system. So this is now an attack machine, basically. So now we can use this one to try to access the resources further down. And normally you don't go for client from here. You would go for servers, internal servers that you can reach.
Yep.
So how do you get to them?
Good question.
It's like I almost know what you're going to do, right?
I mean, of course, we can start looking on that system, see what's there, see if we can reuse anything, see what systems are around.
Well, the problem is that they may have a pretty hard firewall infrastructure. They may not just allow traffic arbitrary in and out of the internal network. So we want to implement some functionality so we can have a covered channel where we can transmit data and use our attack tools targeting the internal network.
So this is what we're going to do. We're going to upload a new file, a new ASPX file called tunnel.aspx. Going to upload. And then we're going to browse to it. Now, this is a tool that is being seen, is used in the wild. I'm going to mention it later in the ransomware session. But what this does is creating a tunnel
from that web server.
It's a web page, right? It's a ASPX file. So it takes request over HTTP. And it will create a SOX proxy on top of that. So you can use basically your applications from here. All applications that are SOX proxy aware, or you can make them proxy aware. They can be routed through this web page into the internal network and all the systems that are reachable from that network. So this is what it's going to look like. On our client side, on our attacker system, we're going to run this command. We're going to run a local proxy listening on the port 8081 with the endpoint, or well, the tunnel hosted there. That's the place where we just uploaded our tunnel. We're going to run it like that. Now, everything we route through localhost port 8081 is going to be forwarded to that tunnel on the server, which in turn is going to forward it to whatever system we're trying to go to.
This is something we see in the wild also.
Yes.
So it's not just something we do in our tests. This is something we find on servers when we do investigations.
So basically, let's just run a simple port scan. We're going to look for anything that exposes port 8080 on the internal segment where the server is. Now, if we bring this in the background, we can see that our port scan is going through the proxy. It's trying to connect to different systems on that port. Some will fail, some will succeed. So we are scanning the internal network through this system. Now, you might not want to start with a port scan. There are stealthier ways to begin with now, but it's a good example for now.
But if you were to do a Wireshark listener, you would see everything running through that server, through the proxy.
Yes. So of course, we can configure our browser to use the local proxy on 8081. In the meantime, the scan is finished. We can see there is another internal system. Well, there is one internal system with port 8080 open. So let's try and browse to that system on port 8080 from our web browser through the local proxy, through the tunnel.aspx. Now I'll configure my browser to use the local proxy on 8081. So 8080, yeah. And this is an internal web application. We can see here that our traffic is being forwarded back and forth. OK? Great. So this application is interesting. We're going to see why in a moment. So just to mix things up a little bit, let's take a different entry point. So that was a classic server-side attack. Let's do a client-side instead. We're going to trick a user into wrong code. OK? This is going to be our victim. It's a guy named Bobby Tables, in case you've heard of him. And he has posted a question on his site. He's trying to figure out why I can't find a file called wcf-test-client.exe, which should be part of Visual Studio, because he's developing some sort of web service and he wants to test it. But he can't find it, so he posted this question on the internet. Where can I find that file? If the server decides to respond. Let me give it a kick. That's better. So that's the question that Bobby Tables posted. Can't find that file. Anybody knows what I can do from here? And there will be someone responding, some random dude responding, yeah, sure. You can just download it from here. You can download it from don'ttrustme.truesite.com/tools, Microsoft, and so on. Sure, just take it from here, and you'll fix your problem. And Bobby Tables will say, well, thank you. That's great. We're going to configure our attacker machine first. We can close that now. Our attacker machine will listen for infected systems. I'm going to use the Metasploit framework and start the listener. This is a free-to-use framework. It has lots of features, including simple things like just starting the listener and waiting for connections. It's going to be waiting for connections over HTTPS coming from infected clients to this server on port 443. So now we are listening. Now, Bobby Tables will download that file, save it. Run it. It will not care that it's not a known publisher. It will run it anyways, because it really needs to fix that problem. And this is the tool he was looking for. This is the real tool he was looking for. Except something else happened in the background now. So if we go back on the attacker, we have a session open. So that means we can interact with that system. Let's do this. We can get a shell, a regular Windows command prompt. Now we're on Bobby Tables' computer. I can run code. Who am I? Well, I'm Bobby Tables. I'm a user in domain called @rip. The next session will be about client-side attacks and ransomware. But we're going to see how this is actually done, how we prepare that special executable that contains the real tool, but at the same time something else happened in the background. We're going to do that together later. For now, just this is the effect. OK, so what's next? So this is compromised. OK. So from here, well, we can try and do different things. It will be easier if we have already a lot of access in the environment. I mean, who is Bobby Tables? We don't know. So let's check. Net user Bobby Tables / domain. Well, Bobby Tables is just a regular domain user. He doesn't have any special privileges in this domain. Good for him, bad for us. What privileges do we have locally? Are we local administrators? Can we, extract credentials and stuff like that? Net local group administrators. Well, administrators here are the domain admins, and then there are 2 local users, 1 local administrator and 1 admin. Bobby Tables is not one of them, so we're not local admins. So we're low privileged. We have low privileges both locally and in the domain. One thing that we can do from here, and that it's not something that, it's something that after you see it, it's obvious, but you might not think about it directly. Because anything that Bobby Tables does now can be done by the attacker. So yeah, we are low privileged, yes, but there are things we can do. Now, Bobby Tables, well, he was trying to develop something. He was writing some code. He's probably a developer. He will have access to some sort of internal development applications that perhaps we can misuse. You remember that Jenkins applications on port 8080 we saw on that internal server through the proxy? That's something that we browse there and require the login. Perhaps Bobby Table has that information. Perhaps Bobby Table has a local account on that system to log on to that application. Let's find out. So Bobby Tables will go about doing his daily work and log on to the Jenkins application. It's a continuous integration tool where you can automate your builds for your software and stuff like that. So he can log on. Good. Now, this was Bobby Tables, so the attacker doesn't know that. But we know there is a Jenkins there. We just want to find access to it. Now, where will that access be from here now? Well, I have an authenticated session. I have most likely received the session cookie from the application with the session ID. If I manage to steal that, I can reuse it and hijack Bobby Tables' session. And I am on Bobby Tables' computer in Bobby Tables' context. So, of course, I have access to that cookie. Where is it? Well, different browsers store it in different ways. So let's make it simple. We just take it directly from the memory. So first, let's try and reach Jenkins. We're going to use PowerShell to make a web request to that URL. And I'll show you why we're trying to go to /script. I guess you can figure it out, but it's a nice feature in Jenkins. So let's try and do that web request first. We have an authentication required. Yeah, well, we knew that. Good. So if we do a task list, we can see what's running on this system. And we can see that Bobby Tables is running Firefox. So let's grab the memory of that process and look for cookies in it. So this is what we're going to do. We're going to download an extra tool called out_mini_dump. It's a PowerShell function that will take a memory dump of any process. We're going to use a technique called invoke expression in PowerShell. Our colleague Kenneth will talk a lot about PowerShell in a later session today, so we can give you more details of how this works. But basically, we're downloading a function and pipe it into, or well, using it into this invoke expression, which will interpret that function in line. We can reuse it here. And well, this will be done in memory within the PowerShell process, so that function will never touch disk. And it's going to save the output into the current directory where we are. Right now here, we only have our test client. So let's run that. There were actually 2 instances running. Let's see which one we really need. Jenkins is 5256. 5256, that's the one we want. So we're going to download it on our attacker machine. We are on 5256. We're going to exit the Windows command prompt. We're going to use this function that is part of the interpreter agent I deployed as part of the client-side attack. So we are going to download that file. It's a 400 megabytes file, so it might take a few seconds. What do we want to do with it? Well, we want to look for cookies. So at some point, there had to be a response from the web application setting that cookie. So we're going to look for a set cookie header. Let's see if we can already find it in what we have so far. Is it here? Yeah. It's almost done, 360. So it should be there. Yeah, now it's done. OK, let's do that. We're finding some stuff. This is it. That's the cookie that defines the authenticated session that Bobby Tables has to Jenkins right now. So let's grab that. I have a few commands later that will use this, so I need to do a small search replace. Of the cookie name, which is also randomized, and the cookie value. All right, all set. Now I can try to do the same thing as I did before when I got the unauthorized message, but I will do it with an authenticated session. So I will create a session. I will give it a cookie with a name and a value, and then I will try and go there again using that cookie. So let's do that. You're going to get a shell again. That's better. Now we got a response, a 200 response from the Jenkins server or application. So if we have Jenkins somewhere here, Now we can access it using the stolen cookie. All right, why did I try to go to that /script functionality in Jenkins? Well, there is a pretty nice feature or functionality in Jenkins. So if you browse to /script, you can test your Groovy scripts. This will be run by the Jenkins application, and you get the output. It's for testing purposes, it says here. Useful troubleshooting and diagnostics. And if you're an attacker, you can use this too. So here you can write your commands, and you will get your output. So I'm going to skip through that, to how to actually do that and how to parse the response. I actually wrote a small PowerShell function that automates all that. So we can basically just use that. Function I call invoke Jenkins command. Again, we're going to download that function and run it in line. And then we can simply call it. We can call invoke Jenkins command, and we can tell it where to go, what command we want to run through Jenkins on the Jenkins server. So let's do an ipconfig on Jenkins. And then if we need authentication, we can provide a cookie name and a cookie value, which we just stole. So let's do that. And this is the ipconfig on Jenkins. So now we are running code here. So this is compromised too. Now we want to get an interactive shell from Jenkins as well. We want Jenkins to phone home directly to the attacker. So we get a direct channel. I will just run something very obscure, and it will happen. But this is what we're doing. Basically, we're doing the same thing. We're calling invoke Jenkins command, except the command is a bit more complicated now. It's a PowerShell encoded command. And what the encoded command is doing is downloading something called invoke shellcode and run it, basically. It's not really complicated. It just looks complicated. So run. And boom, new session, this time from Jenkins. So we can background the current session. If we list our current sessions, now we have two, one from Bobby Tables and one from server 01. Now we are actually running as local system. Why? Well, because Jenkins is running as local system. Because when you install Jenkins on Windows, that's default. So now we are a local system on a domain join server. What does that mean? Well, if we're a local system, we have unrestricted local access on that system. We can extract credentials. We've talked a lot about credentials and hashes and pass the hash and credential reuse and all that stuff. And how high privileged credentials are used to log on to systems on a lower security level. For example, what if a domain admin were to log on to Jenkins doing an RDP or interactive logon? Well, because they needed to manage something, they needed to fix something, or whatever reason. Well, if we list the processes on Jenkins, we have a list of processes and the identity that they're running under. Now, we can see there is this identity, the etarip administrator, the domain administrator of the etarip domain. And this is running some processes. We should be able to see here, RDP clip. It's a classic indication that there is an RDP session on that system. using the domain admin. So domain admin has an RDP session on that system. So if we do a get UID, which is equivalent of who am I in this context, we are local system right now. Being local system means we can extract credentials and also migrate into any process running on that system and acting on with the identity that that process has. If it's an interactive logon, the credentials will be cached or stored on that system for single sign-on purposes. So we can simply do migrate and choose a stable process to migrate to. Let's take Explorer. That's pretty stable. 852. That's the PID. 852. Now, Interpreter will do that for me. It's a nice thing about having powerful agents with a lot of built-in functionality. And if we do get UID now I'm the domain administrator. I'm running in the context of that process where credentials are cached for single sign-on purposes. So whenever I authenticate to something, I directly take the identity of the domain admin. So let's confirm this. Can I do a directory listing on internal.itarip.com admin $? Can I list admin $ on the domain controller? I can, so I'm obviously domain admin. Okay, so we are now here. If this is a DC, now that's compromise. But that has a pretty big implication, because that means that every single machine in that domain is compromised. So now it's pretty easy to hide and look for specific individuals or systems that we are after. So say our goal is a system that is not part of the domain. It's a Linux-based system. And we want to get there. Now, being domain admin doesn't give you direct access to that system, because that's not even part of the domain. But in most cases, that system will be accessed either directly or indirectly from domain join systems. Right? If there is a person managing that system or accessing that system, that could be done from a domain join client, for example. Oops. Say SSH. So as an attacker, we need to find that person. We need to find the credentials used to SSH there, either SSH keys or username and password. And then we want to reuse them to log on to our target system. So let's do that. We have a user, another client here, called Jimmy Chairs. He's friend with Bobby Tables. And he will SSH to that system. So before he does that, let's install a keylogger on this client. Why not? OK. So first we need to find Jimmy Chair's client. Then we want to log on there, install a keylogger, and wait for him to log on, collect credentials, and reuse them. So let's do that. How do we find his workstation? Well, we are domain admins. Let's just ask the domain controller. First of all, let's find that username. So based on certain, this is something we could find. You know, public information will often tell you who is working with what. If you're after a specific type of system, you start targeting all the people working with that type of technology. And we can do this until we find the right person. So we find someone with surname Chairs, and we're going to look for that in Active Directory. And we can see this user has a account name or Jimmy.chairs. Good. So let's see where this user is logging on from. So let's call get win event. We're going to look for Jimmy Chairs. We're going to output that to a file. No events were found. Well, I guess he has to log on first. Okay, should be there now. Yep, let's look at the events. We're going to type that file, see all the messages. We can see an authentication coming from this address. So the 172.16.10.180 is Jimmy Chair's client, at least the one he used to log on now. Good, so we know where he is. Let's go on that machine and install a keylogger. So there are different ways of hiding things on a system. Let's make it fairly simple. We're going to create a VB script, call it logon.vbs, and set that as an auto-run key in the registry. So every time the user logs on, the script will run. Pretty standard and simple. So this is what we're doing. We are going to create a script which will load something from PowerShell, which will be a keylogger, and it will run it. So first, we need to get the script there. So we need to upload it to Jenkins first, and then to that machine. And we need to do that from interpreter, so exit that. Upload that, and we get a shell again. Then we copy it to the client. Done. Now, next thing we want to do is to run a command, in this case, remote WMI. It's another technique of running commands on a system remotely once you have credentials. And we're going to set the run key to launch that script at logon. OK, done. Good, now we just need to wait. So let's sign out. And sign in again as Jimmy Chairs. Let's give it a few seconds for the run key to kick in. You see that small flash? That just happened. OK, so now there's a keylogger running on this system. So with enough time, we'll eventually get to log on to the system we want to log on to. Say 172.16.10.250. Enter We log on as Jim CH, and we log on with my very secret password. Now we're on this system, and we can do our commands. Okay? Assume this is our target system that is outside of the domain. Good. Now we just need to collect that file and reuse those credentials. So that's where the output would be. You would normally name it something different. Yeah, that's it there. Let's type that. There we go. That's the output. That's what Jimmy typed. 172.16.10.250. GMCH is the username. My very secret password. And then all the commands. Okay. Now, just to complete the scenario, we're going to run something called auto-route. That is part of the interpreter agent we deployed, which will basically route all my traffic through the Jenkins system. So I can use any tool from my attacker machine and route it through that compromised system. So we're going to run that. Okay, now we can background interpreter, and we can simply use our SSH client, which now will be a router through the system. My very secret password, and we're now logged on. Okay, so that's red 2. And now we're basically going through here and reaching the system. Okay? So there were a lot of concepts thrown in here. This is, to give you a scenario based on real assignments. Again, this was pretty classic, but then again, most organizations have the classic vulnerabilities to different extent. But they can still be reused and put together and, be combined to reach your goal. And an interesting thing that we can think about when we do these larger assignments is starting to look at timeline and think, okay, how long did it really take until we got our first entry point? How long did it take to either compromise that client or combine those two web vulnerabilities and get code execution on the admin portal application? Is it a week? Okay. Is it 2 weeks? Okay. Is it a month? Is it 3 months? Well, that will change the focus of the attackers, right? If it takes too much effort, they will probably focus their energy somewhere else. Now, once we're in, how long does it take until we get to the first internal system? And how long does it take until we compromise entire infrastructure, in this case, the domain controller? And then, can we find our high-value target? And how long time does that take until we compromise that? And in this entire process, do we get detected? If yes, when? And what is the response from the blue team? So these are all things we can put together and try and prioritize what to do in the environment. Because there are so many things we can do here to improve. But how do we choose what to do first? Well, we need to find the things that really made a difference and try and cut those lines. And if we understand how those vulnerabilities were introduced and what was the underlying reason, then maybe we need to fix something in our process, in our internal routines, or something in our management of patching, or whatever was actually used in the attack, then we can work on that specifically and fix what matters first. So this is a way of looking at it. Fixing the entry points, sure, there must be effort there, but it's really hard to keep it under control. You have a lot of third-party stuff and, you know, client-side attacks, that's up to the clients. I mean, you're going to have to assume breach, or you're going to have to assume that some malicious code is running in your environment. And this is where we can actually make a difference. This is where we can fix our processes and routines and make sure our internal environment is strong enough that even if you run code on a system, doesn't necessarily mean that you can take the entire infrastructure. And just to give you a little something to show now, this is what the White House is telling their government agencies to do. If something happens, you need to immediately deploy indicators of compromise. You need to patch all critical vulnerabilities right now without delay. And you need to work on credentials management. You need to make sure you have practices for privileged users, and you accelerate implementation of strong authentication mechanisms. But we need to start from somewhere. We need to have an idea of what's going on. All right, so that's what I had. So thank you for listening.
Tack Fabio. Ett par ord till bara. Det som slår mig, och jag vet att Fabio har jobbat ganska hårt för att sätta ihop den här demon. Det kanske ser ganska enkelt ut, och det är ju egentligen målet, för att vi måste klara av det vi egentligen gör på flera veckor på en timme, för att ni ska få en uppfattning om hur en sån här går till och alla steg i det hela. Men underskatta inte vad man kan tänka är inte obetydliga system, men liksom ha en känsla för detaljer. För vi tog alltså, eller Fabio tog alltså en hel miljö, och den här miljön vill jag också säga, den är uppsatt så många svenska företag, och internationella också för den delen, ser ut idag. Den har en segmentering, den har en brandvägg emellan DMZ och den interna miljön och så vidare. Så demomiljön har det, men han har använt lite annorlunda kanaler här som ni har sett för att ta sig vidare in i miljön, och det är baserat på verkliga händelser. Sådana som vi ser i våra utredningar, hur de går tillväga. Så genom den här bristen i en extern webbtjänst så tar man till slut över en hel miljö. Det tar tid. Går man in i en av våra war rooms, när vi gör sådana här uppdrag, så är det liksom pilar och kartor, och det är streck överallt och IP-adresser och sådana saker. Så det är ett stort jobb.